Okay. Hi, everyone. Good afternoon. And welcome to the data science demo from Excella. How many of you are here for the first time? Okay. Online folks, how about you? How many of you are attending for the first time? Online folks, am I audible? Please, could you confirm?
Yes.
Okay. So in today's session, in the first 2 hours, I'm again going through the demo for the sake of new participants who are attending for the first time. And later on, in the second 2 hours of this session, we are going to go through the actual content of the program. Okay. Just bear with me who have already gone through the demo. But I'd like to keep it more interesting even for you guys, though you attended already. Okay. Okay, fine. Let's start then. First, we are going to go through the demo of data science. And I'd like to highlight the key features of what exactly is going to be covered as part of this program and the duration of it and the mode of delivery. And taking a step forward, we're going to look through in terms of why exactly that you can choose data science as an opportunity for your career in order to transform from your existing skill to the data science. Why so much of prominence nowadays, not earlier? What kind of demand do you have in the market? And what kind of problems you're going to solve when you when you manage to transform your careers into data science, right? And in addition to that, I'm going to touch base the other aspects as well, which is going to give you the complete a feel of the complete ecosystem. To be successful as a data scientist, what are the things that you would need to learn, you would need to be aware of, and how this program is going to bridge that gap from your current skill set towards the desired skill set of being a data scientist, right? So the program from Excella, the data science, is going to last about 80 hours of duration, the classroom training, which is going to be delivered with a stack of tools, right from the softwares R and Python for the analysis perspective. And you will also be given an insight to the other required skills from the tools perspective as well as from the process perspective, in addition to this 80 hours of duration. This 80 hours of training is purely dedicated for learning the data science. Data science, as part of data science, we're going to learn complete data mining, which includes machine learning as well as unsupervised learning. And in addition to that, we are also going to look at the time series analysis. On top of this 80 hours of duration that we're going to dedicatedly spend in learning these algorithms and the requisite basics to understand these algorithms, and not only conceptually learning these algorithms, but also getting an implementation experience through solving some case studies, right? And in addition to this 80 hours of duration, you can also undergo a visualization training program using the tool Tableau with the dedicated trainers, right? The way, and these trainings will be delivered in both classroom as well as online at the same time. And these sessions will get recorded and will be loaded into your LMS access in no time, so that you can keep revising the concepts which you are not familiar with or where you need to a little bit of assistance to get yourself familiar, right? Just give me a sec, friends. Just pass it on. So is that good enough for you to transform your careers of going through this 8 years of program? We do understand the level of expertise that is required for you to be able to transform your careers. And accordingly, we planned this program to bridge all the gaps. We are not just restricted to delivering this 8 years of online classroom training. In addition to this, to get that implementation experience developed in you, we have planned a stack of assignments as well. However, we are going to pick up a single case study to solve each of these algorithms, to learn these algorithms and see the implementation aspect of it. To get that level of experience or expertise strengthened, we have planned assignments which are going to be part of like 3 or 4 assignments, 3 or 4 case studies will be there for each of these algorithms. And by solving that, you would strengthen your conceptual understanding as well as the practical orientation towards it. And once we are done with the assignments, you can also join us for completing projects, right? And again, these case studies or the projects which I'm going to talk about are not specific to a single domain. We'd like to keep all of your interests intact. Thereby, these case studies and online folks request everyone to be on mute. I'll open up for the questions towards the end of this session. Till then, please bear with me and please go on mute if you're not speaking. Thank you. So these case studies and the projects are not just limited to any of the domains. They're across the domains. And they will develop the required skill set for you to be able to successfully transform your careers, right? Well, this program is going to last about 8 years of duration. And we are essentially talking about the weekend program, which is 2 to 6 in the evening. So that means you'll be attending 10 consecutive weekends on both Saturdays and Sundays for the next 10 weekends, starting today, right? So this entire data science program is going to be delivered using the softwares, both R and Python. Why are we learning R and Python? Why not other tools? We always need to understand the demand that's there in the market. Accordingly, we plan our programs to be able to upskill, right? Thereby, it fits for you to be able to transform, right? And both these softwares, R and Python, being the open source softwares, they're highly encouraged across the domains, across the sectors. Though we have other tools, other softwares that are available to perform this data analysis in the market, in the likes of SAS, SPSS, organizations have started moving away from those tools. And very few organizations are still stick to these tools, SPSS and SAS, because of the fact that they comes with a huge license cost. We are in the era of open source. Organizations are not ready to pay for the softwares that you make use of for your analysis, unless those analysis turns out to be beneficial. But they're not ready to pay a single penny, right? And that's where these two tools have started grabbing the market. Because of the kind of strong support these tools have got, these softwares have got from the respective communities who manage these tools, softwares, in terms of releasing the packages for solving complex problems, for solving the same problem, different approach, different way of solving the same problems, by providing more and more insights. And that's where these two tools have managed to capture about 95 to 96% of the market. Yeah. I would request everyone to please write your names and sign on that paper which is being circulated if you miss out at the first place. Yeah, thank you. So both these softwares, R and Python, have captured 95 to 96% of the market space. So that means that many number of clients who are actually having these analytical operations, they are using these softwares. Hence, it is quite obvious for us even to learn these softwares to be able to transform your careers, right? And do we have only these tools? Don't we have any other softwares? Yes, of course we do. The Spark, to be able to work on the big data environments. I'll come to that point as well, right? And we will be learning each of the algorithm conceptually first, because it's very essential to learn the crux of the algorithm, how the algorithms work. Unless and until you understand how each of these algorithms work, you would not be able to make use of the respective algorithms to solve a specific problem. Because these algorithms can be used to solve multiple problems, not just one kind of problems. Right? Hence, it is very essential for us to understand the crux, the internal logics of how these algorithms work. And then we're going to pick up a case study for each of these algorithms to see how do we build the models using both R and Python one after the other. How do we do the pre-processing? How do we build the models? Do we build only single model? Not definitely. We'll end up in building multiple models for solving a problem. But how do you evaluate performance of these models? And obviously, we would like to pick the best performing model out of the stack of models. How do you take it? Right? And how do we promote it to the production? It's a complete end-to-end life cycle we will be learning, right? And in addition to these softwares, as I discussed, there will be another 20 to 25 hours of dedicated training will be provided on top of this 80 hours for the data visualization using Tableau. So once you are familiar with the data science concepts, that's when we suggest you to go through this data visualization program. So why exactly we need data visualizations? Any idea, friends? Representation of the data in a more meaningful way and more catchy, so that clients can make, business teams can understand the complicated or more complex things using a very simple diagram, right? Though you go to them with 1,000 lines of description, nobody will have the patience to go through with the same intensity that you have taken to draft them. But a single picture, a single visualization graph will talk the same amount of things, but in a more catchy way, right? But why is this data visualization is so important? And the organizations have been spending so much of amount and efforts in terms of streamlining their business so far, from 1990s till 2005-6. They've been implementing the ERP packages to be able to streamline their business. In addition to that, we are also listening in terms of the data management, like the data warehousing, right? Which pulls up the data, and on top of that, you generate some reports so that the business will be able to take some informed decisions that the data is speaking, rather than relying on some assumption, or rather than relying upon some heuristic-based rules, right? But can you make out everything? That what kind of actions as a business that you need to take just by looking at the graphs? That's quite impossible. And that's where the gap has opened up in terms of the organizations to understand how exactly their business is running, where they are lacking, where there is scope for improvement, and what kind of further actions would be able to attract more customers or increase their customer base by analyzing the data that the business has managed to generate over the years. And that's where the huge gap opened up for someone who can actually analyze the data and let the business teams know what kind of decisions would be more beneficial for the business so that they can run for longer term, right? And in addition to these softwares, as I told, the trainings will be delivered both classroom plus online at the same time, the way our online participants are attending, right? And will be uploaded to your LMS access. LMS is nothing but learning management system, where these sessions will be recorded while they are being done. And they'll get uploaded to your LMS access so that they're available for you to revise and to clarify your doubts, to get yourself familiarized with the concepts at your own pace, right? And in addition to this, you will also be given the full-length recordings for data analysis using SaaS software. You can ask me, Ram, you just told us that organizations have started moving away from these tools. Why are you still providing it? It could be like the remaining 4 to 5% of the organizations, if you are part of it. And if you are given an opportunity, provided you know the softwares and skills of data analysis, there it will be used. But however, the algorithms, concepts, whatever we are going to learn using R and Python would still be intact. You will be able to catch up just by following the recordings. Just the navigations, those things you need to understand. In addition to that, we also need to be equipped in terms of understanding the overall ecosystem. What do I mean by overall ecosystem? Is it something a data scientist is going to work completely independent? Not, of course. Has to liaise with the business teams to understand the problems, what they've been going through. Then understanding the statistical relevance of those problems, building a pipeline of the projects, that how many of those problems can really be solved using data science, and getting in touch with the data engineering teams to understand the source of the data, right? And then once you manage to pull up the data, perform cleansing, do the pre-processing, build the models, prove your hypothesis. And finally, for deploying the models, you get in touch with your architects or the production deployment team, right? It's a complete life cycle. Data scientist is not going to work in silos, right? In order to bring that flavor to you, you'll be given a full-length recorded sessions for Hadoop. And that might raise a question. Person who would like to become a data scientist, does he need to have the big data knowledge? We are not intended to become big data developers or integration developers. We would like to understand the source of the data. If it is a HDFS based data, how do you extract it? how the big data as an overall framework, how it works. What is distributed computing? How can it boost up your computations? Because we cannot keep working on a single machine or laptop for solving such a complicated problem. We end up in pulling millions of records. Just to perform a simple calculation, it takes hours and hours. We cannot be so unproductive, sorry. That's where we rely upon these distributed computings, GPUs, graphical processing units, TPUs, tensor processing units, so that we get the earlier feedback. Thereby, we take the correct decisions in terms of whether a particular model is performing as per our expectations or not. If it is not performing, what kind of techniques do I employ? Okay. So that's where this Hadoop recorded sessions are going to help you in terms of understanding the overall framework of big data, so that you will understand the source of the data, right? But even before that, even before talking in detail about what we are going to learn as part of this 8 hours program, we also need to understand, can I really think of data science as a long-term career opportunity? Or is it like any other technology which comes and gets outdated in the next couple of years? We've seen so many tools, softwares came up in the market, where the entire industry keeps talking about those softwares in no time, and they get outdated in the same pace, right? So can I take this data science as a career opportunity for longer term? Longer term in the sense, I'm not talking about 1 or 2 years. I'm talking about at least 10 years, right? But to get the actual picture at the ground reality, we need to understand certain facts about how this as a skill has evolved historically, so that gives the confidence for you to be able to. Folks, am I audible? Okay, fine. So that it gives the confidence for us to take the right decision, right? But what is big data? Any idea, friends? What is big data? Huge volumes of the data. Friends, one of your webcams has turned on. Could you please turn it off? I think I know who is that. Money, I think your webcam is on. Could you please turn it off? Okay, fine. Big data is nothing but huge volumes of the data that organizations have been managed to generate over the years by deploying certain ERP systems, or capturing their business data in a structured format through some database deployments. Could be any of it, right? But if you look at the volume of the data that's being generated, till 2003, the entire world managed to generate about 5 exabytes of the data. But what happened after 2003? Because of the digitalization, the storage cost has gone down drastically. And the technology started picking up very fast in the area of smartphones, the area of developing advanced infrastructure-based machines to be able to perform complex computation, right? And internet is available at a good speed. So because of all these facts, the same amount of 5 exabytes of data started getting generated in every 2 or 3 days. So from 2003 onwards, you can just imagine the amount of the data that kept accumulated with the organizations. But why are we talking about data science only from last few years, not before that? Is it because of these algorithms were not developed? Is it because of that we don't have enough skills to be able to handle these algorithms, customize these algorithms to be able to solve the business problems? None of them are a reason. These algorithms were available to us right from 1950s and 1960s. Mathematicians, statisticians have started developing these algorithms right from 1950s and 1960s. But what we have been waiting for? We have been waiting for just the data. We didn't have enough data to be able to make use of these algorithms and solve or take intelligent business decisions. Right? Now you can imagine the amount of the data would have been generated from 2003 till date. And what is the pace at which, the velocity of the pace at which this data is getting generated? How many users are being logged in Twitter in a duration of 1 minute? How many hours of videos are being watched over YouTube in a span of 1 minute across the world? How many transactions Amazon managed to generate in a span of 1 second? 1 minute. So that explains the pace at which this data is getting generated. It also gives us an assurance in terms of, so do I have enough data? Is there enough data available for us so that this data science is going to be flourished for next 10, 15 years easier? Without data, being a data scientist, we can't do anything. That's the first and foremost requirement for us, right? And looking at the types of data that's getting generated, is it only the structured data being generated? Structured in the sense, typical rows and columns format. Could be capturing typically in the databases through some ERP's deployment, right? It's not just structured data. If you look at the proportion of structured data versus the unstructured data, structured data is hardly about 20 to 25% of overall data that's available for us. Then what is unstructured data? Which is there for the remaining 70-75%. It could be the text that people exchange over the internet, social media, for expressing their ideas, views, or for rating a product that they have bought, the reviews that they have been giving over the different e-commerce platforms. Okay, it could be an audio speech. When we call to a customer care, the first and foremost disclaimer that they give us is this call is going to get recorded for the quality and monitoring purpose. You can just imagine the amount of audio speech data that is available for the organizations to be able to analyze and take better decisions. It could be a video data, images. Look at the driverless cars developed by Google. What do you think, how it takes the decision in terms of by seeing an object, whether to stop or whether it can continue? Right? Because of the sensors that's being deployed in all the corners of this car, the real-time images keeps getting captured and will be accumulated over the cloud in no time on a real-time basis, right? And analytical framework, which could be the neural network based models, support vector based models, would run on top of that at a very brisk speed and would pass back to the controlling system of the car the information whether the object which you are seeing in the image, is it something that the car has to be stopped, can continue, right? So this unstructured data, look at the proportion of unstructured data, is there for 80% of the data. But what kind of opportunities do we have in analyzing both the structured and unstructured data that we are going to see in a while, right? But having so much of data getting generated, what exactly, to what extent organizations are making use of the data that's getting generated over the years? Right? Seriously, the organizations are drowning in the data. Too much of data getting generated. But do they really have the skill to be able to analyze the data and transform that into profits? There's a serious shortage. If you have 10 data scientist requirements, there are only 2 or 3 data scientists available in the industry right now. For every 10 jobs, 2 people are available. There's a serious shortage, right? And let's look at few of the sectors, understand how fast the data is getting generated and how big the data is getting generated. If you look at the banking system, the debit cards, credit cards, each swipe that you make would generate a transaction. What kind of analysis they can perform, and thereby they can take some intelligent decision. Or partnering with a particular mall, would that really help to actually increase your cards usage? If most of the transactions are happening over the weekends in a mall, how many of your machines are being deployed to be able to transact, to allow the vendors to transact? Right? And if you look at the stock prices, what all factors would influence in terms of determining a stock price? It could be the competitors' decisions. It could be the government policy changes. Yeah. It could be a kind of better product introduced to the market, thereby the products of your own might start getting declined or not being picked up by your customers. Various factors, microeconomic factors, macroeconomic factors. You can just imagine the amount of the data that would get generated in very short span of time of a stock price being taken into consideration. To look at the retail sector, we pick up a basket and walk into a brick and mortar store. Brick and mortar store is nothing but the physical store. We pick up all the items what we want, and once we are done with the shopping, we comes back to the till, the POS system, where the billing will be done. The person who is there in the till picks up each and every item that you have collected into your basket. He scans it, right? And once you're done with the payment, you will be given a bill. What exactly happens in the background? So stocks will be updated accordingly. The replenishment request would be generated at the same pace. Replenishment is nothing but like replacing the items which were already picked up by the customers based on the leftover stock. And what kind of items are being moved together? People who are buying a bread are also buying a jam. What kind of jams they are picking up? And bread and jam is a kind of fast moving item. Most of the people picks up, right? Being a retailer, you should really aware of such transactions which are being moved together so that you can manage your stocks accordingly. And that also gives you a kind of upfront information for you in order to manage your supply chain by placing the respective orders with the vendors or the suppliers, right? And if you look at routers, is basically a media organization. You can just imagine the amount of the data that would have been available with them, because they've been in the media from decades. Kind of articles they have published, and not all articles would get published, and some of them would have been stopped because of whatever the reasons. The kind of analysis that they come up with, unless they understand whether the customers who are going through this are liking it or not, are they feeling it, they're useful or not, they would not be in the industry for so many decades. But how do you get that insight in terms of the products or services that I'm selling are really of attractive to the customers or not? And that's where the data science is going to fill the gap for the organization, right? And if you look at the Netflix, the moment we watch a movie or a web service, it's basically known for the web series, right? Netflix. Once you watch it, what is the immediate thing that you will see, you will observe? Sorry. Yeah, it comes up with the recommendations in terms of people who have watched a similar kind of genre, similar kind of the action or drama or whatever it is. And you could also get a recommendation from the same directors, movies directed by the same director, or the hero was been part of that particular series, right? How these recommendations will be generated? If two persons log in at the same time and watch the same video, do you think that the recommendations that Netflix would generate will be the same for both the users? Yeah, it's completely different. It's based on the recommendation engines. Okay. Going to identify the people who have got the similarities and identifying the similarity matrix of all these customers and their respective watching pattern. And also for searches. Have you searched for any movie previously? Right? And the kind of ratings you provided, for the kind of movies that for which you provided the ratings, all these things will be taken into consideration for generating that recommendation. And these recommendations needs to be so powerful to be able to transform the prospective customer to a sale in no time. Hence, they have to be accurate and very powerful. Hardly we spend about 5 minutes time while doing a shopping on an e-commerce website. With that 5 minutes, you should be able to convert, or you should be able to increase your sales as much as possible. Personalized recommendations, personalized strategies, right? Now, the pace at which data is getting generated. We just talked about the number of hours of videos being watched over YouTube in 1 minute. It's 4.5 million hours of videos are being watched. And 1 million active users or logins are observed over the Twitter in 1 minute of time. Right? $0.9 million worth business is being observed on Amazon. $0.6 million hours of videos are being watched over Netflix across the world. Right? So this is the pace at which the data is getting generated. The whole reason that we are talking about the pace along with the underlying facts is to get an understanding in terms of, is it a long-term opportunity that I can rely upon or not? Okay, fine. This is all perfectly fine. We discussed about the historical evolution of the data facts. But do we have such requirements in the market right now? These are some renowned facts that have been published by various organizations or the agencies who have got some reputation. Harvard. We all know there is a lot of credibility for the articles that Harvard had published. Harvard has clearly called out that data science is going to be the most attractive job for 21st century. Yeah. LinkedIn, right? The data science profession is popular, successful, and maturing. And we can also do our own research in terms of what kind of opportunities do we have? Because we mostly rely on Naukri for changing our jobs, right? So we can do our own research. What kind of opportunities do you have to what level of experience profession? Is it only the most experienced professionals who are there in the industry would get an opportunity to work as a data scientist? Being a fresher, do I have any opportunity set up? Data science is not just limited to any level of experience. We do have openings for all levels of experience, right from a fresher, 1 year, 2 years of experience to till 15 years, 18 years, 20 years of experience as well. The reason being, the kind of benefit this analytical wing or the data science wing is going to bring to the business. Data science is not just about programming. And of course, we do program, but not to the same extent of seasoned programmers like Java developers or .NET developers. It's more of analytical, logical thinking. To be able to interpret the results, what you are observing, or transform those results as a business benefits. So to carry out this level of work, you definitely need senior people who can actually manage the business teams in terms of understanding their business problems, do the stakeholder management, project management. And you also need mid-level of people in the range of 6 to 7 years of experience to right to till 14 years, 13 years of experience. To understand those business problems pretty quickly and collecting the data and questioning the business teams of any concerns, any clarity that you are required. And you also need low level of experienced people to be able to follow the seniors' guidelines and complete the level of analysis that is required. So it's not just limited to any level of experience. The doors are open for all levels of people. Okay. And you would be hearing a lot of jargons in the industry. Data scientist, data analyst, okay, machine learning engineer, business analyst. What exactly these roles are about? Is there a specific difference, or is there a stipulated difference, or a standard difference between these roles? From a conceptual point of view, as of course, there used to be the data analysts who used to perform just the analysis based on data. People have been using Excel for years to perform the analysis, to generate the metrics that they would like to see. And if you typically see the business teams who have been sticking to a particular organization for 20, 30 years, most of them would still be using the Excel to perform this complex calculation. Right? The business analyst, request of the page. Okay. Okay. The business analysts are typically interacting with the product teams or the end clients to understand their requirement, capturing that requirement, and doing the feasibility study of your current landscape of the system, then transforming those requirements through the development life cycle. Thereby, you can realize or you can make use of those features. Right? But when it comes to data science, it could be a data analyst, could be a data scientist, could be a machine learning engineer, or could be an analytics professional. There are no barriers. It requires right from interacting with the business, capturing the business problems, transforming those problems into the data science projects, and solve them using the softwares that we are going to learn. Build the dashboards that are required for the business to be able to easily understand what kind of decisions they need to take. Right? At the same time, what are the teams we get in touch with? Integration engineers, data engineering team, business analysts, architects, right? We're going to work with all these teams to be able to understand the requirements, understand the source of the data, capture the relevant features for solving your problem. Okay. It's all perfectly fine. We have looked at the volumes at which the data is getting generated, the pace at which it is getting generated, the types of the data, and what kind of requirements we have in the industry. And let's also take a step forward and understand what kind of problems would I be solving if I choose this career path and manage to transform my career into data science. Right? And let's look at different sectors. Let's first talk about the telecom. What kind of problems these telecom operators are suffering with for years? These telecom operators end up in spending so much of money for acquiring a new customer, right from the promotions, advertisements, and the more attractive tariff plans by compromising on their profits. They shell out a huge amount of money for getting a new customer onboarded. But the biggest problem that they're suffering with, because they spend so much of money to acquire a new customer, they cannot afford to lose that customer even without having him for longer term. Only if the customer sticks to that operator for more than 6 to 8 months, only that's where they start seeing the break even. The biggest problem these telecom operators are suffering with is the churn. What is customer churn? Any idea, friends? Yeah, the customers who are turning off from that service provider. That means mobile portability, what it has done to Indian telecom operators. People shifted left and right from one telecom operator to other telecom operator. Right? This customer churn is a serious problem that the telecom operators have been living. But how data science is going to help us to solve this problem to an extent? May not solve completely, but how it can help. Being a data scientist, if you can analyze based on various facts, how many customers are going to churn in next few months because of what reasons? If I know that information upfront, would I not be in a position to take corrective decisions or preventive decisions? I would not call that as a corrective decision. It's more of a preventive decision. Provider might reach out to the customers who are of concern, understand their pain areas, and try to rectify the problems or give them more offers. Right? And we have been hearing about the network infrastructure thefts, because these network infrastructures tend to be in a very remote areas. How can they control that? Because if your service is out for at least an hour, you can just imagine the amount of loss you are going to incur. You cannot afford to get into that kind of situation. You would have heard about IoT. What is IoT? Internet of Things. So all these manufacturing things are the equipments that are being used to produce something. They would be monitored by connecting through the internet. Right? Sensors would be deployed on the would be deployed on the most important equipments of your infrastructure. And we keep monitor the health of these equipments continuously. And if at all there are any signs that an equipment could go down, that we plan the maintenance phase rather than getting into the complete out-of-phase phase, which is more costlier. Right? GE, the manufacturing giant, you can just imagine the volume of the vast manufacturing units that they need to maintain in order to cope up to the requirement. Because most of our daily routine items that we make use of are being generated, are being produced by GE. And it's not just good enough to produce the items. It also need to be reached out to the customers or to the suppliers or the vendors who has kept the orders with. How do you manage your transportation to be able to cater to such a huge demand? Right? The transportation sector has been highly revolutionized the last few years because of the technology that is available to be able to monitor and reduce the outage times and increase the most efficient usage of these vehicles. Right? And if you look at automotive, we keep hearing in the news that a particular automotive giant come out into the news asking a batch of production cars would need to come back for a maintenance phase to rectify a small problem, saying that it has got a minor issue in the dashboard or in some other area of the vehicle. Yeah, it's the most renowned one, right? But can you really afford to keep coming out into the public and give such kind of announcements more frequently? What kind of impact it would leave on your prospective customers? And people will definitely think twice if we keep coming out in the market and make such announcements very often. People would definitely rethink about, oh, is my decision is the correct? Am I going with the correct option? But what is causing them to get into that kind of bad situation? It's a definite leakage of the defects from one life cycle of the development or the production to other life cycle, other phases. Right? The phase containment of your issues. Being a data scientist, if you can analyze, the production of different shifts, of different manufacturing units, and based on the historical facts, if you can come out with a prediction that a batch of production could get leaked certain defects, can't you take a preventive action rather than again reinventing the wheel again? Right? And similarly, we just talked about the recommendations. Amazon. Because of the cutthroat competition that we have in the market for these e-commerce platforms, they don't have a legacy to sell the products at their own wish. If you ever dare to do that, you will be out of the market very soon. Because of that, they had to operate with very little margins on the products that they sell. Rather than looking to gain on each product that you sell, they work on volumes that you sell. Right? And thereby, it has become essential for them to be able to increase their sales through various strategies. To be able to gain the sales, to be able to improve the sales, thereby they can improve their margins. And that's where the recommendation systems plays a crucial role. And also the association rules to understand what all items are being sold together more frequently. Right? Okay. Now let's spend some time on what exactly that we're going to learn for these 80 hours of duration. People in each team. So these are the day level topics that we're going to discuss. So we highly recommend, as and when we complete a topic of discussion in our classroom, please pick up the assignments from the respective topics and please start attempting. Okay. If you can give at least 2 to 3 hours of time every day for next 5 to 6 months, then the rest will be assured for next 10 to 15 years. Okay. Exceller has got a consulting wing called InnoDatatics, which actually starts developing some products and some POCs for developing solutions for different clients. Alongside of that, having that as an inspiration, we started doing the projects as well. So we highly recommend once you complete the assignments, you can go through a couple of projects. By the time, whatever projects are ongoing, you can choose one of them and be part of them. So we will be having minimum 2 to 3 teams formed for each of the project, of 5 people, 6 people in each team. And we will be competing within the teams to produce the better models and best quality code for solving a problem that is being taken into consideration, right? And that gives very much real-time like experience in terms of the moment you join a project. What exactly you do, you're going to get all such learnings, right? And these are some projects that we're currently doing. Predicting the flight delays and predicting impurity in ore, minerals. Okay, predicting the oil price and electric motor temperature optimizations. Twitter data analysis for a product, NLP based project. And we have another NLP based project to highlight the top 5 relevant answers for the questions that you search for, right? So we currently, these projects are ongoing. Once these are done, we will be launching a new set of projects. It's a continuous process, right? So alongside of assignments and project support, will also help you. Excella will also assist you in terms of profile building, resume preparation, and mock interviews, conducting the mock interviews. Thereby, if at all there are any gaps with respect to your knowledge, the kind of exposure towards a particular area that is required for you to be able to gain, it will be suggested, and you will be prepared, and will also help you in building your LinkedIn profiles, wherein most nowadays 60% of the times the recruitments are being taken place through the LinkedIn, right? And these are the assistance that Excella extends along with this program. Alongside of this, Excella has also got a tie-up with various organizations, and Excella started setting up a recruitment panel where few of the HRs would be part of it and would keep publicizing or would keep marketing your profiles to various requirements that the industry is having from different organizations to increase the chance of getting placed. Okay. Doesn't mean that you just need to go through this way. You can also try out simultaneously on your own. If it works, that's perfectly fine. Yeah. And these are the clients with whom Excella has got the tie-up. Or 150, more than 150 clients Excella has got the tie-up with. And the TCS, with TCS, Excella has got a tie-up, and you will be assured to get an interview call, and you need to go through the exam, because you should have minimum 2+ years of experience to attend that exam. And if you clear that, you will be given certification as well, right? And the placement is purely up to your performance in the interviews, right? Any domain, because it's through Excella, they will take it as a certification. Yeah. Even before opening up the form for questions, I would like to go through some common questions that we generally get to hear from the participant. After this, I'll take up your point. Yeah. I don't know how to code. Can I learn data science? We are not a seasoned programmers. Being a data scientist, you need to have more of a logical and analytical thinking. Technology is not something which is very hard to learn. Concept is something which is typical to learn, complex to learn. Okay. So don't have any sort of programming experience. We understand that. That's the reason we start with right from basics of R programming, basics of Python programming. We will take you right from the basics till the level of expertise that is required. Do I need to learn both R and Python? Can I stick to only one? It's up to you. We will be delivering this program with both R and Python, considering the kind of opportunities we see in the industry. It depends on where you are flourishing or what kind of calls you are getting. You can just lean towards it more. Okay. Can a fresher learn data science? And of course, it gives a definite edge for the fresher from the pool of people that are available in the market with a definite certification and with the kind of work you will be able to showcase over the Kaggle, GitHub, right? It definitely improves the chance. I have 10 plus years of experience. Can I pursue data science? I've been into a particular domain from the last 10, 15 years. To learn this data science, would I be able to transform my career? Yes, of course, you'll be able to. We do have a lot of testimonies with respect to the same. A lot of people who have undergone the program. They managed to transform their careers and they're doing good as well. As I told, data science is not just about programming or not just about domain expertise. It's a mix and match of everything, but ultimately our analytical and logical thinking takes the first priority. Right? I'm from civil or mechanical or pharma or finance background. Can I learn? This is especially for the business analyst or the subject matter experts. Yes, of course. If you look at the business analyst job opportunities that Amazon is looking for, they expect business analysts to come out with the machine learning skill. The traditional way of analyzing for the business analysis is no more. They do expect even the business analysts to come to have or to procure the machine learning skills, right? And what is the average salary for a data scientist? And definitely from your current salary, you could expect 150 to 250% of the hike. You can do the comparative analysis in the Naukri, right? We also know that there are 3 different types of the skills. Hard skills in the industry, which we have been hearing for the years, where at some point of time, SAP data warehousing, there used to be hard skill, right? Which is no more. And these data science opportunities will definitely be able to fetch the salary and more than people who are being referred as a hard skill. And what are the domains this data science has been picked up? Irrespective of the domain, all the organizations have started setting up their analytical wings, their data science operations. Otherwise, they lose the competitive edge because their competitors have started setting up. If they start getting benefited, if they come across new ways of running the business, these guys will not be able to pick up in the market, right? If I learn data science, how much percentage of hike I could expect? That's what I just answered. How much time I need to spend to crack a job in data science? If you're an Einstein, if you can pick up things in the first instance, that's perfectly fine. By the time of we complete the course, you should be able to transform your careers. But generally, what we had observed is basically it requires minimum 5 to 6 months of time. And if you're ready to devote 2 to 3 hours of time every day, you'll be good to go ahead after 6 months, including the project. Provided you're giving commitment for completing the assignments and taking a project, then 6 months time, you will be ready to be able to market yourself, right? So with that, I'm done from my end. Now I'm open for the questions. Online folks, I would request you guys to please post your questions in the chat window. I will take up those questions once I complete with the classroom participants. I'll take up all those questions one after the other. Okay. Any questions, friends? Classroom? Okay. Deep learning is also a part of machine learning, but whereas as part of deep learning, we will be exercising more intensive computations using GPUs, graphical processing units, TensorFlow processing units. But the kind of algorithms we will be using in the space of deep learning are more of CNNs and RNNs, convolutional neural networks and recurrent neural networks. It's more of reinforcement learning where we expect the models to learn on its own as it passes through the new trends and new patterns in the data. Okay, but as part of machine learning, we cover the artificial neural networks, where we give a kind of introduction to the neural networks, and we will also cover an introduction of CNNs and RNNs as well. But deep learning is something which you can expect to be there after practicing the machine learning at least for 1.5 years to 2 years. Yeah.
One is how
So from a training perspective, we expect you to come along with the laptop with at least 8 GB RAM. Okay, if you have 16 GB RAM, that's well and good, because the kind of data sets we are going to load for case studies, what we are going to go through for each of these algorithms, would not be able to occupy even that much of RAM unless we start with the project. Once we get into the project, that's where we go with the real intensity or the real volume of the data. But when it comes to the distributed computing or the databases or the ERPs that we have been talked about so far, we will not be able to provide that infrastructure. But we will give you the conceptual understanding and the technical approaches that are required to be able to approach those kind of situations. But we will be able to practically give an exposure with the data sets that we have. We expect you to come out with a laptop, and we will also show you how to install R, RStudio, Python, Anaconda, okay, including all the IDEs like Spider, Jupyter, and PyCharm, right? We expect you to come out with your own laptops with at least 8 GB RAM. It's going to be equally distributed with R and Python. But as I told, we spend most of the time in understanding how an algorithm works, which is the crux of it. And most of the interview questions will also be on how these algorithms work. When it comes to the practical aspect of it with R and Python, we give equal importance for both the tools. And let us say in a span of 2 hours, we're discussing about the linear regression, both linear regression, simple linear, multilinear regressions. And we give about half an hour to 40 minutes for model building towards the end of the session, right? The remaining we will be covering. Like if we cover 1.5 hours for the conceptual understanding and various other tactics that we need to be equipped with solving different problems. We'll be talking for the first 1.5 hours. For the next half an hour, we will look in both R and Python one after the other, the model building and the. Okay, fine. So R is far more easier compared to any other language, any other programming language, because it is a function-based programming language. And most of the R functions are very much similar to English, what we refer. Okay. And we highly recommend the people who are purely from business domains and who don't have any sort of programming expertise to start with R program. But people who have got a bit of exposure to OOPS concepts, okay, and for them we recommend Python. But again, it ultimately depends on for which software you're getting more calls. So ultimately, you need to be placed. Otherwise, there is no point in learning this course for and again putting effort for next 6 months. Okay, so once you pick up R, it's not difficult to transform your learnings to Python. No. The Python and R programming, the basics of Python programming, basics of R programming, we are covering a weekday classes for about 5 days. Each of these two will cover 5 days, 2 hours a day, about 10 to 12 hours of program for each tools, each of these softwares. But as part of this weekend program, even I do cover the basics, but not to that level of detail. We expect you to go through that once it is available so that you will be picked up. Yeah. Sorry, please repeat. Okay. No. Okay, fine. So ultimately, we do concern about the source of the data. The source could be your Azure cloud, your AWS cloud, or it could be a data lake, completely a custom data lake that most of the organizations are building on their own nowadays, or it could be a typical data warehouse structure itself. Irrespective of the source of the data, okay, we pick up the data wherever it is available. Yes, exactly. Okay, so these ETL engineers, they are responsible for collecting this data or integrating the data from multiple databases into the data warehouse. Okay, you will have a purging process where in terms of maintaining your historical data for years and years. But being a data scientist, we are going to extract only the data that is relevant for the problem what we are solving from the respective source. It could be a data warehouse, it could be a SQL server, it could be Oracle, it could be MySQL, it could be Hadoop-based HDFS files. Okay, it could be any source, or it could be in the on-premise system, or it could be on the cloud as well. Doesn't make any difference for us. And sometimes, if at all the organizations are already having the data engineering teams operated, so the data engineering teams help the data scientists with the structured data in the requisite format first. We work with them and they will know which system they need to extract the data and they put it in a structured format and hand it over to us. Okay. So this basics of R programming will last for 10 hours, which is going to be taken by a different trainer. We have next level trainers. Okay, and basics of Python programming also will be taken by on the weekdays itself by a different trainer. But what I will be covering is, I will also be covering right from the basic statistics. I will be covering basics of R programming and Python programming, and slowly I'll be increasing the intensity. And we will be writing the models which are of foremost efficiency when we reach towards the end of this program. Right? So we are not just limited to the basics in any of these streams. Right. Okay, fine. So as part of the analytics, there is a kind of confusion in the industry. Okay, or different organizations refer that in different terms. As part of the analytics, most of these reports are being developed. Visualization reports are being developed, which is being run on top of the data warehouse. Okay, based on the historical data that's been saved. Thereby, business has been referring these reports to take some informed decisions if they would like to raise a purchase order with a certain supplier for next one season. They do capture various reports, and based on that, they run some sort of analysis, and then they're finalizing the quantity for which they would like to raise purchase orders. But this data science sits not even part of ETL, not even part of reporting. It sits a standalone way, okay, which is going to work in collision with all these teams. Okay, we coordinate with the data warehouse teams or the ETL teams or the data engineering teams to understand the source of the data and to extract it. And we complete the analysis. We present back the results to the business. Once they are convinced, we'll again integrate with the data engineering teams or the production deployment teams to push these models into the production. And the data visualization engineers will develop the requisite dashboards in terms of presenting, beautifying the way of seeing these results to the business. Exactly. Exactly. Yeah. Yeah. It's more of like a solution architect. Hmm. Could you please come again the last part of it? Mhm. Mhm. Okay. So we need to be mindful that we are going to make use of these machine learning algorithms and unsupervised learning algorithms to solve those problems. Okay. That's where this skill is altogether different from solution architecture or the business analysis. Because neither the solution architects nor the business analysts have got the understanding of how can they use these algorithms to solve the complex business problems. No, data engineering is all about integrating the data from different sources. It could be a big data engineer, or it could be an integration engineer who works with or who migrate the data from a data warehouse or a standalone database to a cloud-based database. Data engineering is altogether a different thing. Okay. Yeah. As part of the R tools, we start with the data types and storage types, and what all kind of operations we perform on these different storage types. How do we aggregate the data? How do we perform the cleansing? And how do we carry out the pre-processing? These will be covered in your pre-processing in both R and Python. Sorry, could you please come again? Okay. Are you asking about the projects which I just discussed, which are being done from Excel? Okay. Hmm. Okay. Most of the times, the fund for the data scientists would get released from the business teams, because we work very closely with the business teams in terms of solving their problem. Okay. And from technical aspect, yes, we do integrate or we do coordinate with the technical architects of the who knows the complete architecture of the system. Also, of course, the business analysts and the data engineering teams, if at all they are there. Yeah. So these are the teams we are going to work with. So data scientists are going to be kind of its own wing, will be operated on a standalone mode. But of course, we do keep all the stakeholders up to date with respect to the kind of updates. And mostly we would be reporting to the business teams. Any other questions, friends, from the classroom before I take up questions from online participants? Okay, there's a question from Shamolimo. Yeah, online participants will also be helped with resume building and mock interviews. Yes, of course. So once you are done with the assignments and projects, you can reach out to the sales team saying that you're done with all these things. You would need help on the mock-up interviews and resume building. Yeah, they will redirect to you one of the trainers or the mentors. So they will be able to help you. And we do have dedicated team of data scientists, the lead data scientists, who are currently catering this particular assistance in terms of building the resumes and conducting the mock-up interviews. Okay. Yeah. So there's a question from Subramanian. Are you covering statistics as well, concept-wise? Yes, of course, we are covering basic statistics as well, right from the measures of central tendency, right from the data types, measurement scales, okay, and measures of variance, skewness, kurtosis, central limit theorem, and the G distribution, T distribution, standardization, normal distributions, yeah, hypothesis testing, confidence intervals. All these we will be covering the topic wise. Did I answer your question, Subramanian?
Yes.
Okay.
Thank you.
Yeah. So any other question, friends, before we break and come back for to start with our actual classroom training? Interview from the organizations? Yeah, that's what the placement cell is going to assist you. Of course, you have to take up the interview. We will assist you with all the required skills, and you can also get in touch with the interview mentor to be able to understand what kind of questions might come based on the job descriptions and all those things. And once you're done with the interview, if you'd like to understand new things that you have faced in the interview, you can also get in touch with them. It's a continuous improvement process. We help you to improve yourself. Yeah. Okay. Thanks a lot, friends, for your time. I hope the information is useful. And we will take a break of 15 minutes and come back and start with our actual session. Yeah. Thank you. Well, Shamolima, to answer your questions, these weekday classes are purely for the basics of programming on R and Python. Of course, in the weekend, yeah, I do cover that, but not to the same level what you get to see in the weekday classes. But his weekend class is purely complete program of this data science, which covers all these basic statistics, programming of basics, as well as algorithms and solving the case studies using these softwares. Yeah. Is that helpful? Okay, fine. Okay. Time now. Let's come back by 4:15, friends, and we'll start with the session. Thanks. Ganesh, Hanu, Hema, Leena, are you able to hear me? Okay, fine. So as part of the first session, today we're going to look at various types of analytics and the end-to-end life cycle of a data science project to give you an overview of how exactly being part of a data science project, how it works. Okay, and after that, I'll start with the basic statistics. And different types of analytics. Diagnostic analytics, predictive analytics, descriptive analytics, prescriptive analytics, right? Diagnostic analytics, as the name suggests. Why do we go for diagnosis of a particular disease? How exactly we diagnose whether a disease is existing or not, or the intensity of the disease, right? We make use of certain equipments to test whether the symptoms of a disease existing or not in us through the diagnosis. To understand why exactly, what is the basic reason for us to get into that particular situation, to understand the root cause of it. That is why we go for this diagnostic analytics. And descriptive analytics, as the name suggests, we try to give more details about the analysis what we perform. The descriptive analytics, let us say, if I come across a forecast or prediction that 5% of the customers are going to churn in next 3 months because of these 5 reasons. Identifying or predicting the percentage of the customers who are going to churn my services is not that difficult. We can make use of statistical techniques that are available to us and the packages or the algorithms that are available to us to derive that level of information. But associating a reason as to why the customers are leaving me of different segments has to be required. Some sort of in-depth analysis needs to be done. So when I label a segment of the customers are leaving me because of the poor network quality in their area, that labeling process is nothing but descripting or providing more description about the area of my analysis. And that's called descriptive analytics. And predictive analytics is something what we are going to do for next 8 years. We're going to predict whether a customer who has taken the loan will get defaulted or not. If a student who is appearing for the exam will be passed or failed, based on the historical data, we're going to analyze the patterns and the trend that's existing. And we're going to come out with a conclusion. We're going to come out with a more confident decision about the future of what it is going to be, looks like. Means we are predicting about the future based on the data what we have historically. Right? And prescriptive analytics. When we approach a doctor, we are not well. First, we describe about the issue that we have. Then he suggests some diagnosis. He asks us to go through some scan, X-ray report, or some other test. Once we get the report, and based on the experience, based on the domain experience, the doctor is going to prescribe a medicine to us to be able to recover from that problem what we have been facing. That's nothing but the prescriptive analytics. Yes, of course, 5% of the customers are going to leave my services because of the poor network quality in their respective areas. Then what kind of action I'm going to take? Is the network quality needs to be improved? Do we need to throw more promotions towards those customers to keep them happy? What makes them happy? To not take some adverse decision. It's about the prescriptive analytics. These are the 4 broad classifications of analytics: diagnostic analytics, descriptive analytics, prescriptive analytics, and predictive analytics. Right? We would be hearing more of these when you start working as a data scientist? Is it visible, friends, towards the last? How about now? Still not satisfied. Descriptive is just about what kind of insights you make by analyzing that. Unless and until you are in a position to carve the solutions, you cannot call that as a prescription. Prescriptions is something which are going to be devised by developing some strategies to counter the problem what you are observing. It can only be taken by the domain experts. Prescriptive analytics. Being a data scientist, you would be doing the predictions, and you can also tag a label towards as to why you are seeing that particular behavior of the respective customers as part of descriptive analytics. Diagnostic, of course, provided you have the required infrastructure equipments to come out with the respective reports. And most of the times, this diagnostic analytics would need the help of your respective equipments. In case of healthcare, we do have all these MRI scans and all these things to come out with the diagnostic report. But after looking at all this, the business who are being the experts of your domain are going to carve or design a strategy to improve the satisfaction levels of those customers. That's called prescriptive analytics. And to be able to work on prescriptive analytics, you should be placed very close to the business teams. And which is a kind of very rare opportunity. Maybe once data science as an industry starts maturing, that's when probably you would expect those kinds of situations. But business have been suffering with even more complex problems, which have to be solved at the first priority before we reach to that level of interaction. Yeah. So next, we are going to discuss about the end-to-end life cycle of a data science project. The moment you are part of a data science team or machine learning teams, and some of the organizations call them as machine learning engineers, some of them called as data scientists. Yeah, but ultimately the underlying work, what you're going to do, will be the same. It depends on the kind of organization you would be entering in. Here, I would like to talk about mainly three types of organizations. One is the businesses, they maintain their own IT teams, like Walmart, like Mercedes-Benz, like Ford, like Greens, like Vodafone. The main area of survival is running the business. And to support that business running, they also maintain their own IT departments. And being a data scientist, you would try to get into those kind of organizations because you will not have any limitations or you will not have any restriction to access the data, to propose a problem that you think would be more important to solve. You will have all the freedom. and your votes will be taken into consideration. And the next level of organizations are the product-based organizations. I'm talking about the IT-based product-based companies. Means these companies build a product by analyzing the features from the market or based on the competitors and based on various other factors. They build the features into their product and they sell these products for the end business users to run their business. So you will get into a different ballgame. You are part of data science teams in IT product-based company. There, you would need to play a crucial role in terms of deriving the most important features that your product could have so that it increases the customer's traction. It's not only the features, but also you can come out with building some dashboards. Dashboards are not just the reports. These dashboards could be the outcome of different models that you built based on the problems what you're solving. Right? So you will end up in playing a different ballgame. You're part of IT production. And the third type of organizations is going to be the pure service-based organizations like Accenture, TCS, Wipro, Infosys, where provided you get some project from the client, you will be solely working on that project. So of course, it would be challenging to work on such projects, provided you got a client who gives you the freedom. Majorly, you can think of these three types of opportunities in the industry to get into. It doesn't mean that you will not have any encouraging work in any of these three types of organizations. I'm not saying you'll have the least important work in any of these type of organizations. It depends on the kind of problem what you're solving. Each and every problem is far most important for us. Right? And the moment you're being part of one of these organizations, the first and foremost thing for us, being a data scientist, is to understand what business problem we are solving. Sometimes your business teams would not be enriched enough to guide you in terms of what problems needs to be taken up at the first place. So in those cases, you would need to speak to the business teams and understand various problems that they have been going through for years and years. Out of that, prioritize the problems. And being a data scientist, you should be in a position to judge what kind of problems can be picked up as a data science project, or what kind of problems cannot be really proven with the data science. So the process of converting all these business problems to the structured business projects, it's called building the pipeline of data science projects. And mostly the people who are with more than 10 years of experience would end up in playing this role. Because you should have domain expertise, a bit of domain expertise. You should know how to deal with the business teams. And you should have a holistic understanding of how data science works. Only then you will be take the decisions on a fly. Right? Once you complete building a pipeline of these projects, and do remember that it's far most important to understand these business problems to the level of granularity that is required. Don't ever hesitate to schedule multiple meetings a series of follow-up meetings with the business until and unless you are clear about the problem, what you're solving. Because data science is a skill. We don't need to be so good in a domain to be able to crack or solve a data science project. You might work in telecom now. You might go to manufacturing for the next project. You might go to banking afterwards. You don't need to be good in all these domains. And of course, the business teams and the business analysts would be there to help you, to get you an understanding of the problem what you will be solving. And sometimes some of the business analysts or the business teams who are matured enough, who are there in the business from the last 20, 30 years, are good enough to guide you in terms of what data would help you. Otherwise, if you just land in a new domain altogether, and if you thrown a business problem and thrown a database in which the data exists, you cannot just analyze the complete data that is there in your database. You'll have millions of records, right? Hence, it is very imperative for you to understand the business problem what you're solving and get a hint of the relevant data that could be helpful. A 15 to 20% deviation of the data might still help. That can be proved statistically. Maybe like if you consider 20 variables or 20 dimensions for solving a business problem. Having more data in place is perfectly fine, but having less is a problem. Because that means you're still missing out a feature which would have been picked up for better prediction. So that 15 to 20% deviation, more or less, could still be proven statistically. Thereby, you can go back to the business, say that somehow we are missing some more important features. I'm not able to predict to the better extent with the given data. Can you think of any other data that could be helpful? Okay. But if you have more data, yeah, statistically, you can prove which are the variables or features that are not at all helpful for your output prediction. Remove them from your analysis. And that's why we have to be very clear about the problem, what we are solving. And once we are clear about the business problem, that is when we start with data collection. As I told, if the business teams are matured enough, they will be able to help to an extent in terms of what data needs to be collected. If they're not matured enough, yeah, you have to move on a trial and error basis based on some hints. So definitely we'll get some hints from the business teams or the business analyst. So ultimately, it's their responsibility to let you know what could be the relevant data that you might need to consider for that business problem. Right? So once we collect the data from different sources, that's where we get in touch with the technical architect in terms of what all the systems are being running in the landscape of the business. What data lies in what system? If the data lies in a particular system, how far into the history we have the data available in the system? Depends on the kind of problem what you're solving. You would need to understand. You would need to decide. Is that last 1 year data is good enough for me to predict for next 1 month? Is the last 5 years of data is good enough for me? Depends on the problem. And depends on the problem, unless and until you try out, no one can really judge which approach is going to be the best. Unless you see the result, no one will be in a position to talk. Hence, data science is all about experimentation. We don't rely on the assumptions. We rely on only the facts. Unless we see the results, we don't believe. Okay. So once we collect the data from various sources, then obviously it depends. Let's talk about the structured data to hit the low hanging fruit at the first place. We'll talk about the unstructured data when we get into text mining. Okay. Even in the structured data, it is always possible that we might have a lot of the data missing. So some customers or some customer executives who acts as the end clients may not enter some of the information which may not be the mandatory for updating a particular transaction, right? Thereby, you would be missing a lot of data in you. So once we collect the data, that's when we start with the data cleansing. As part of the data cleansing, we look at how much of the data is missing, what is the proportion of the data that is missing, and do I really need to have that value to be able to predict my output value? If at all, I definitely need to have some data in place of this missing, because data collection is the costliest effort. Because business deploy the ERP systems, they run various campaigns, they give various advertisements, and they shell out huge amount of money for the renowned people in the society to advertise for them. And after shelling out so much of money, that's when the customer walks into your store or approaches you to buy your service or to buy your product. Only then the data will start getting generated. Hence, removing the data should not be an option for us at the first place. As long as possible, we would need to impute the data, impute the missing data with some meaningful information. There are various techniques we resort to with respect to imputation of missing data. Right from the basic imputations like mean imputation, mode imputation, we do have the complex imputation techniques like model-based imputations, various advanced imputation techniques that are available. So we resort to all these techniques and we fill in the missing values. And then once the data is in a very structured way for us to be able to carry forward for the analysis, that is when we carry out with the subsequent phase of our project. So far we discussed about business problem understanding, data collection, data cleansing. The first three important steps. And that's when the next most important phase starts, called EDA, exploratory data analysis. Exploratory data analysis or elementary data analysis. What exactly we do as part of EDA? Part of EDA, we're going to look at univariate analysis, bivariate analysis, and multivariate analysis. What exactly are these univariate, bivariate, and multivariate? Univariate is understanding or analyzing a single variable at a time. Variable are nothing but the dimensions, features, the columns that we have in our data set. And what all kinds of analysis we perform as part of univariate analysis, right? From measures of central tendency, measures of dispersion, skewness, kurtosis, to understand the shape of the data. And if at all we have outliers, what kind of influence they will be having on the generalized outcomes, right? All these things we are going to perform as part of univariate analysis. Then we get into bivariate analysis. So at the first place, we analyze each of the variables independently, individually. In case of bivariate analysis, we take two of the variables together and understand the relationship between those two variables, between the input variables, between the input variable and the output variable. What kind of relationship they are sharing, how the correlation looks like, right? Is it giving any kind of insight? Once we are done with that, that's when we get into multivariate analysis. As part of multivariate analysis, we perform the most important analysis that's called feature engineering. Feature engineering is all about understanding the most important features for predicting an output value, output variable. Do we need to transform the data? What kind of technique do we need to resort to as part of feature engineering? Is it forward selection, backward elimination, stepwise selection? Right? And there are also some ways of proving how important a feature is considering the output variable along with the other input variables. We resort to all those statistical techniques to understand the most important features of the variables in our data. And then we get into the model building exercise. Guys, if you take the duration of a data science project for about 3 months, all the steps that we discussed so far till the model training, business problem understanding, data collection, data cleansing, data wrangling, right? Understanding your infrastructure, understanding your software set, understanding the existing architecture of your system, EDA, exploratory data analysis. All these steps would take at least 60 to 70% of your project time. The success of your models depends on how much success you are on these preliminary steps. Right? So as part of model building, we take the complete historical data. We already discussed that we need to define the time frame of this historical data that needs to be picked up. It could be 1 year, last 1 year data, could be last 5 years, last 10 years, depends on the problem what you are solving. This entire historical data will be partitioned into two data sets. One is training data. The second is test data or the validation data. So we make use of only the training data to build the prototype or the candidate model. The finalized models that you build on just the training data are called as candidate models or the prototype model. Once you are satisfied with the result of your prototype model on the training data, how do we gauge the performance of the model? So even before testing it on the test data, we should have a measure to understand or to gauge the performance, right? Based on the accuracy of the model, based on the error. Accuracy and error are two measures that we take into consideration for gauging the performance of the model, whether those accuracies or the errors are in line with our expectation or not. And they're also helpful in terms of comparing multiple models that we build. We will never end up in building one single model for any problem. As I told, data science is all about experimentation. Unless and until you try it out, you will not know which model gives you the best result. Right? Hence, we need to develop that skill of more research orientation experimentation. When we approach a new business problem, you can perform various amount of research in terms of what kind of work was done in the area of the problem what you are analyzing. Yeah, of course, the problem which you are solving could be highly customized towards a client for which you are working for. But still, being a domain or being a kind of the problem, you are not the first one who are going to solve such problems. There are enormous amount of scholars who have done the research in majority of the domains. Now, of course, the data which you are capturing is different, and the way the client is running the business would be different. But you get leads, you would get a high-level information about what could be the more relevant information you can depend upon while solving the problem by going through these scholars, articles. A lot of work is happening in the area of data science on a day-to-day basis. Even you would get to understand while building a pipeline of your projects, data science projects, you would get to know very interesting use cases that people are actually experimenting or solving given a domain. They might also be helpful for your client, right? So once we build multiple models for solving the same problem, to gauge the performance of or to select a model which is the best performing out of all these models, that's when we will make use of this accuracy and errors. The accuracy and error that you derive out of the model that you run on the training data are called training accuracy and training error. Training error may look pretty straightforward, but we would resort to different measures of error, like RMSE, root mean squared error, like MAPE, mean absolute percentage error. These are different measures which we can rely upon, gauge the performance of the models and pick the best performing. Right? We always need the best, right? And once you prove the candidate model or the prototype models that you built are performing to the required satisfaction level on the training data, that is when we go for validating it or testing that model, because we have exposed the complete data of training to build the model. The model knows what all trends that are existing in this training data, what all patterns. Yeah, it knows completely about the data. But the training model, the candidate model, what you built, has not yet seen what type of data that we have in the test data. The reason being why we are testing the model's performance using the test data. Using the historical data, we are building a model. And if we deploy that model into the production, we will not know how that model performs in the production when it keeps observing some new data coming on its way. Right? On a day-to-day basis, business generates the data. The whole reason why we are building this model is based on historical data, we are building a model. The moment I deploy it, on the new data that's getting generated, so this model is going to run and give the predictions. We will not know how it's going to perform on the unseen data. That unseen data, to explore the model's performance on the unseen data, is the underlying logic here. That is the whole reason we are validating the performance of this candidate model on the test data. And even when we run this model on the test data, we capture the test accuracy and test errors. Right? But again, there are some problems we will generally get into when we're comparing the performance of the models between training data and test data. There could be overfitting problems, there could be underfitting problems. And we resort to different techniques to solve those problems. We might develop a transformed version of the model to counter these problems. Various assumptions we take into consideration. Depends on the model what we are building. Depends on the algorithm for which we are building the model. Once we are satisfied with the performance of this model on the test data as well, and that's when we recommend or we take that model forward for the production deployment to generate a seamless solution for us, seamless predictions for us in a day-to-day business. We would schedule the model to run at a particular time in some non-business hours. It keeps running on a fly and generates the predictions on a fly and display that in the required dashboards for the business so that they can take the better decisions. And it is not just good enough for us to leave this at that itself. Being a data scientist, understanding with the business teams and the architects, you should be able to simulate the cost calculation framework or benefit realization framework. The moment you generate these predictions, and obviously some subsequent process of your business is making use of these predictions to gain more benefits, it is going to reduce the cost, your operational cost. Simulate a cost calculation framework. Thereby, we can tell the business teams that, okay, if we accept this model to be deployed into the production, I'm going to save this 5K euros per month, 5K dollars per month, 10K dollars per month. And that is where the work as a data scientist, what you're going to do is directly related to the cost savings or the revenue growth. Now, don't you think if someone is saving that much money for the organization, who is directly reporting to the business, would not be valued to the same extent? Of course, we are making use of the softwares, but we are not a cost header for the business organization. We are a revenue generator for the business organization. We are a benefit realizer for the organization. We are the cost saver for the organization. Am I clear, friends? And there we will also look into various types of frameworks that we can make use of to deploy these models into the production. And of course, as we discussed, we will be developing the models based out of R as well as Python. We will be looking at different frameworks to deploy these models into production by using R Shiny for deploying R codes, by using Flask for deploying Python codes into the production. These are the integration enabled packages which you can actually run this on top of the database, intended database. And alongside of that, there are different frameworks that the industry is practicing already. Okay, like your model would be converted into a web service, and that will be called by the relevant app server like Apache, and would run it automatically on the intended database where it is pointed to at the scheduled time. You would have heard about some schedulers, right? What is a scheduler that is existing in a big data environment? Any idea? Thanks. Different technologies have got different way of scheduling the things, scheduling the jobs to run at a specific time, right? And once we deploy the model into the production, it is not the end of the data science lifecycle. Based on the performance of the model and the test data, you are assuring the business teams that it could perform better or to the same extent, even on the production as well, which may not come. Hence, you need to define the monitoring period for which you're going to keep monitoring the performance of the model on a day-to-day basis. And keep sending a report as to how best the model is performing, even in the production on a daily basis. The business gain the confidence of the right. So once the model, if the model is performing pretty nice, even in the production, to the level of expectation or beyond the level of expectation, that's perfectly fine. You would observe or you would monitor for a certain period. And how do you define that period is again depends on the problem you solve. Has it got any seasonality? Has it got any trend? For how long you would need to be assured of the performance that is required, right? Various things that needs to be taken into consideration. And we are going to discuss all these things in detail as and when we discuss about respective algorithms. Okay. And for suppose the model's performance starts dipping down. That's when you take the model back into the maintenance mode. You again capture the new data, retrain the model, fix the problem, then deploy it again. Clear? And there we follow different approaches. As and when we are experimenting something for the first time, which is a complete drastic change, the way you are proposing to run the business by deploying a model. You may not make that as a primary model. A primary model could be the existing way of running the business. And you would develop a secondary database by taking a clone of your existing database. And you keep running your model on the secondary database, generates a report on a daily basis, shares across to all the stakeholders. After observing it for a few days, if everyone agrees, yeah, it's doing great, then make it as primary and just go away from your existing way of running the business. There are different ways of gaining the confidence of your customer or the client or the business teams, right? So this is about the overall end-to-end life cycle of your data science process. So any questions, friends, so far? Online folks, any questions?
No questions, thanks.
Okay. Classroom participants, any question? I like the classes only who ask more and more questions. Okay. I don't really mind spending half an hour in answering your question. Whatever the slightest doubts you might have. And of course, yeah, a lot of terminologies which are used, they are not aware of. They haven't gone through. Right? But at the same time, like being your current experience, taking into consideration. If at all you feel any questions to be asked, don't step back. Okay. So the life cycle, this picture is little. First, we capture the business problem. We understand, then we acquire the data, understand the environments, and understand, cleanse the data, pre-process the data with respect to the problem what we are solving. That's when we go for model building. And finally, we get into the production deployment. This is the reason why these arrows mention that it could fall into any phase is if your model performance while building itself is not good enough, you might come back and collect a new set of data. You will be moving back and forth unless you will be able to fix the problem more streamlined way. And sometimes business, the problem could be required to revisit the moment you start looking at the model's performance. Even the business problem itself might needs to be revisited. So any change in a business problem and obviously will impact the subsequent phases. But if you take the straightforward flow, first we understand the business problem, then we acquire the data, we cleanse the data, we wrangle the data as per the shape that is, as per the structure that we need for the model to consume, and we build the models, we train the models, we test the models, Thereby, we evaluate the performance of different models. We select the best performing model and deploy it into the production. Okay, fine. Right. So as part of the model training, we are asking or we are instructing the machine to learn based on the data that we are providing through the algorithm we are using. These algorithms comes up with the capabilities of solving different problems in different ways, different approaches. As part of the model training, we're going to produce all the data and we're going to tell by using this algorithm, and this is the output I would like to predict based on these inputs. You might think that, okay, it's so simple, then why do you need a data scientist to just tell these two things? It's not that straightforward. It's about understanding the correct statistical relationship of the output variable with the respective input variables. If required, we need to transform and we would need to standardize the data. We would remove the scaling issues. Various things that we perform. I don't want to overload you guys in the first session itself. So slowly, as and when we get into the topics, I'll slowly increase the complexity or the depth of our discussion. Right? Any other questions, friends? Okay. The training data is we will be using just to train the candidate models, the prototype models. No, the test data and training data are two different subsets. These two are part of your historical data. Let's say you would like to predict the sales or forecast the sales for next 1 month. Yes, Shyamalima, I'll take up your questions. I got a question from the classroom. I'm taking it up right now. I'll take up your question after that. Okay. The question from the classroom is, what is the difference between training data and test data? Let us say, I would like to predict the sales, forecast the sales for next 1 month. Means for the month of October of 2019, I'd like to predict the sales. So for that, based on the analysis, based on the discussions, and also after proving based on different statistical methods that are available, if we think that last 1 year data is sufficient enough to forecast for next 1 month, because that covers seasonality, because this October's sales might have a correlation with last October sales because of whatever facts. Okay. If at all you observe any such kind of trends. So I'll be taking last 12 months of data. So this entire 12 months of data becomes my historical data, wherein what is the output variable we are predicting here? We are forecasting here sales, right? So for the last 12 months, do I have the sales data available in my system? Obviously, we will have, right? Along with the input variables, what we think that are useful for sales prediction, I will also capture the output variables, both input as well as output variables. Then I'm splitting this 12 months of data into training and test. Wherein I'm keeping 6 months of data for training and 4 months of data for test. That means, so I have the data captured till September of this year from October of last year. From October of last year till September of this year. So I'll have the very recent 4 months data assigned as part of test data, because of the fact that it is always suggested to keep or assign or partition the most recent data as part of your test data. Because the data which you are providing for the model to train is almost about 4 months old. Because you are taking the first 6 months of data. That means effectively from October of last month till last year, October of last year, till May of this year, covers about 6 months of data. 8 months. Oh, sorry. We have 12 months of data, right? Let's say this is 8 months. Okay. From October of last year, October of 2018, till May of 2019 is 8 months of the data. So the data that you are using to train the model is already 4 months older. So if the model that you are generating out of this old data will be able to withstand to the performance that it gives on the latest 4 months data, then we can believe that the model could perform better even in the production, which is the future data. And this proportion, data partitioning proportions, 8 months, 4 months, 60%, 40%, 80%, 20%, 10%, these all different combinations we have to try out. No one can say this is the straightforward answer. Even though someone tells you, don't believe. Unless we see the result, we will not know how it performs. So out of the historical data, we are splitting the complete data into training and test and assigning the most recent data to the test to understand the performance of the model. As long as the performance of the model is up to the satisfaction level or expectation level between both training as well as test, then we cannot really promote that to the production. Only if you are satisfied with the accuracies and errors that it is generating, only then we can promote that into the production. Am I clear now? Sorry? Doesn't necessarily. You can always give 60-40% between training and test. You can give 40-60%. Because if you're working with the huge data, billions of records, then it is very little chance left for you to learn, for your model to learn new insights beyond a limit. There, 40% of the data itself is good enough for your training. Depends. Unless that is the whole reason we cannot say anything which is going to work 100% correct for any of the situation. It's purely depending on how the data looks like. And that's the whole reason, though we have a lot of automated services available, the cognitive services, which Azure Cloud has developed, okay? And IBM has come out with a kind of analytical engine. AWS has got its own analytical engine, which generates. The moment you just produce the data to it as an input, it gives 4 or 5 different models. But if you look at the accuracy of the models, it will be 50%, 55%, not up to the satisfactory level, right? Unless and until we try out, we cannot believe anything. And that's where these automated services cannot replace the role of a data scientist. Any more questions, friends? So I'd like to wind up here for today. And tomorrow when we meet at 2 o'clock, I'll be starting with the basic statistics, right? It's going to take about, for next 6 to 8 hours, I'm going to discuss purely basic statistics. And I'll also pick up the basic R programming and basic Python programming. After that, I'll discuss the hypothesis testing. How many of you prefer to have a class next week? Because that is a Diwali. You would like to prefer to have a class, or? Okay, you are not going. Because I do take care of the morning session as well. Those people are already opted out. That's perfectly fine. Based on your availability, in which ways I am available, I'll be able to take up the class. Okay. And tomorrow, let's meet again at 2 o'clock in the afternoon. But tomorrow onwards, we'll start with the actual content of the course. Right?
Thank you, sir.
Yeah. You can attend the online sessions like our participants are attending. We'll discuss tomorrow. We'll again discuss and take the voting, and based on that. Yeah. Thank you, guys. Thanks for
Thank
attending.
you. Bye-bye.